My name is Dr. Andrew Van Benschoten. I am an adjunct professor of artificial intelligence here at the University of San Diego. I also have the pleasure of serving as the Director of Advanced Analytics and Insights at Winfield United, a large farmer-owned co-op in the Midwest. So computer vision is the process by which we can teach AI algorithms to recognize in images objects, people, occurrences, and then do something with that information. And this is an extremely important topic in the field of artificial intelligence because it sits right at the intersection of software and hardware. I think for many AI practitioners, many data scientists in the field, we only really think about the software side of things where we're just writing computer code that perhaps talks to other computers. But in order to have a fully functioning robot, to bring AI to life, perhaps outside of the computer, you need to give that robot or that system the ability to know something about its surroundings. So you can't really have an effective robot that doesn't know where it is, doesn't know what's going on around it. And so that's why computer vision is so important, is that it's bringing AI to life in the real world, if you will. When it comes to talking about how AI learns to recognize images, I think most people would be surprised to learn that AI starts to understand the world the same way that we do. What we do is we train artificial intelligence systems by saying, this is an image of a chair. This is an image of a dog. This is an image of a ball. And through repeated exposure, the model can learn what a chair, what a dog, what a ball is. And then we go one step further and say, here's a picture of a chair that might be rotated, or here's a picture of a dog running. We start to make things a little bit more difficult. And very similarly to the human brain, what that does is it takes kind of this foundational static concept, and then on top of it adds a degree of dynamics that you might see in the real world, because we don't just have people standing or sitting in one awkward pose in the real world. People are doing things, they're moving, and that's true of all objects, of all things. And so by that two-step process, we're able to get a good foundation for what a model can recognize in the real world. And on top of that, what we're going to often do is we're going to give that computer vision system real-time feedback. We're going to say, okay, your job is to identify planes taking off from an airport. We can go back and we can look at what objects you classified as a plane and what objects you classified as a bird. How well are you doing? Are you accurately identifying the objects, or do you need a little bit of help? And by doing that, we can understand where the model is doing well, where it's doing poorly, and then help teach it and lean into those areas where it needs a bit of extra knowledge. One of my favorite examples of computer vision is self-driving cars. So many of us are familiar with automated taxis or a lot of the electric vehicles like Tesla. The self-driving features feel like magic. At the same time, that is largely because we have spent years building these computer vision systems to see, to detect. People might be interested to know one of the ways that the post office actually classifies and deals with all of the mail that's still sent a hard copy. Think of all the handwritten addresses. You can't go through and read them all. So what computer vision does is it enables workers at the Postal Service to sort and move at speed so much faster than they ever could have before. Another great example of where computer vision can really help us is self-checkout lines. Instead of having to wait in line at the grocery store, you can imagine a world where you take a shopping cart and you move it through a computer vision system that can recognize and detect different objects and say, these are the items you bought, this is the amount we're going to charge to your credit card. Another great one is in the field of agriculture. You need to get a sense of how is my produce faring, the corn, right, that I harvest. What's the quality? Are there concerning signs that might mean I need to think about how I plant and grow my corn next year? Is this healthy corn? Is this something that we can use for human food, or do we need to think of something else? So there's a lot of real-world applications where computer vision can drive efficiency and prevent waste. To me, the reason that everyone should know about computer vision is that AI is slowly moving from the computer screen into the real world. We see all these flashy examples of humanoid robots and the like, but even more fundamentally, It's slowly creeping in through self-driving cars, through self-checkout lines, through facial recognition systems. And so to understand how these systems work and how they connect both the hardware and the software side of the world, it's going to give people an understanding, but I would say also a sense of ease to understand that this isn't some black box magic. These are systems that we understand and that we know. And for any aspiring AI practitioner, I only see the fusion between hardware and software increasing in the future. So to me, this is one of the areas that almost every data scientist is going to need to know something about as their career progresses in the years ahead.